Have you ever wanted to capture user inputs as part of a Hype project? Inputs like the text associated with a username, an email address, or a phone number. Or even the answers to a series of quiz questions. If so, you probably already know there is no native way to do this in Hype, and instead, it requires some coding, which can be a turnoff for some people. In this video, I'll demonstrate a simple way to capture and validate user inputs in Hype with minimal fuss. My method utilizes everyday HTML input tags, regular expressions, and some custom CSS. This approach employs a small amount of JavaScript and CSS code, but don't let that put you off. It's quite straightforward to implement in Hype. Later, I'll show you how to adapt this code to evaluate different text input types with only minor changes to the initial code. If that sounds interesting to you, let me show you how this works in a sample Hype project I've made. Here is a screenshot from that demo project. It's just a simple login dialog that you might use to collect different text inputs from a new user. In most cases, you'll want to validate that these inputs are in the form you expect, and are ready to be used by your program. At launch, each input field starts in a blank state with some placeholder text, like this image. While each of these inputs is a text string, the preferred format of that string is quite different in each case. Therefore, each field will need to be validated against a different set of rules. Those rules and how to apply them is what this video is all about. This process works so that when a user begins to type into any of these fields, the program immediately starts evaluating their input against a regular expression that defines a valid input. Regular expressions are the magic that allows this process to work with minimal coding. In my example, incomplete or invalid inputs, like those shown here, will display a red border and some hint text under each field, letting the user know what's acceptable. Once a valid input is entered, the border for that field is colored green, and the hint text is hidden again. You can see this in this image. You might be worried that the code to validate these inputs is long and complicated, but in fact, it isn't, and that is due to the power of regular expressions, or, as most people refer to them, regex. I'll explain more about these regular expressions in a minute, but first, let's review how to set up these text input fields in Hype. The most convenient way to capture text inputs from a user is to use a regular HTML input field. To set up one of these input fields, I'm going to add an HTML input tag to an empty Hype container. To get started, we'll need to generate that empty container. You can do that by simply dropping a rectangle shape directly onto the Hype canvas. Eventually, you'll want to remove this element's border, and any color fill, because they won't be needed once we set up this input field. But for now, I'll leave the border visible so it can be seen on the canvas. Next, you need to get access to the inner HTML of this element. You can do this in 3 different ways. The simplest way is by double-clicking on the element itself. Once you do that, the element border changes color, and a small button pops up at the rectangle's base, here. Clicking on this button pulls up a blank dialog window. Into this window, you can potentially paste all kinds of HTML, CSS, or JavaScript code that help define the appearance and behavior of this element. However, I'll paste in some regular HTML code that I have previously copied to the clipboard. The other ways you can access this inner HTML dialog are from the Edit menu, using the option labeled Edit Elements Inner HTML, or by using the keyboard shortcut Command, Option, E. You can see how this code includes both the input tag to set up the text field and some explanatory text enclosed between a pair of p tags. This is also where we define the placeholder text that appears in each field prior to the user typing any input. Inside this input tag, I've also added a type designation. In most cases, this designation will simply be text, except for the password field where we want to obscure the input. Once we add this code and click away to hide the inner HTML dialog, you can see that the original element has been replaced with a field that's ready to accept user input. Remember, this is nested or embedded code, and there is no sign of it in the resource panel. So, the trick here was to add a regular HTML input field directly into the inner HTML of a blank element. Once we have that input field, our next task is to validate and process that text input. We do that with a small amount of JavaScript that is loaded when this dialog first opens. To do that, we need to attach a new function to an onSceneLoad event in the Scene Inspector panel. I've done that here, and I've called this function SceneSetup. The JavaScript code I've added to this function looks like this. Let me walk you through each step and explain what it does. In case you were wondering, all the green text here is explanatory comments. They have no functional role, but it's helpful to understand what this code is doing and in what order. The first step in this function is to get a list of all the input fields in the scene. That's done with this line of code. Next, you'll need to define a series of regular expression patterns for string validation. We'll use a different pattern for each input field because the rules for an appropriate username are obviously different from those for a phone number. For now, don't worry too much about this syntax. I'll explain more in a minute. The following code block defines a validation function that determines whether there is a match between these regular expressions and what the user has entered. Finally, I've added a series of event listeners. One for each input field. That code looks like this. These event listeners listen for key-up events from each input field, and when it detects one, it runs the validate function. Consequently, this function is run after each new keystroke, and this works to give the user immediate feedback by changing the border color of the corresponding input field. We change the appearance of these fields in a consistent fashion across all fields by adding different CSS classes to indicate whether the input is valid or not. I'll show you how that is accomplished a little later. For now, let's go on and dig more deeply into regular expressions. Regular expressions are a way to describe patterns in string data symbolically. You've already seen some examples of these regular expressions in the scene setup part of our code. It's easy to recognize this kind of syntax because regular expression code is always contained between a pair of forward slashes. Sometimes regular expressions also include one or more flags, or modifiers, that are positioned after the last forward slash. These flags toggle on or off various options such as case sensitivity. String patterns defined this way can be used for all sorts of find and replace operations, or for input validation of phone numbers or email addresses, like we're doing here. These regular expressions are not formally part of JavaScript. In fact, regular expression syntax is not even a full programming language. Rather, regular expressions act like a mini language running alongside other languages or as a feature built into other products like Excel. Fortunately, regular expression syntax is almost uniform across all programming languages, so once you learn the basics, you can utilize it in any language. Unfortunately, regular expressions are difficult to interpret because they have a very compact syntax that's unlike any other language, and it often ends up looking like gibberish. This makes them notoriously difficult to decode or construct from scratch. So, my goal here is to help you recognize where and when to use these regular expressions and how to source reliable examples that you can use in your hype code. Let's look at some of those options now. There are a lot of good tools online to help you build, test, and debug regular expressions. Two sites that I've found particularly useful are regexer.com and regex101.com. Both of these sites allow you to test or refine your regular expressions interactively. It's much more efficient to fine-tune a regular expression in one of these workbenches as they give you precise feedback regarding an expression's validity, together with the capability to run quick tests. More importantly, they also contain numerous examples of common regular expressions that you can simply copy and paste into your project. These examples are particularly helpful because they were made by experts and have already stood the test of time. If you are interested in learning more, these sites also have tutorials about regular expression syntax. Once you've identified a suitable regular expression you want to use, the next step is to incorporate it with the string manipulation methods made available by JavaScript. We'll do that next. JavaScript comes with a handful of built-in string manipulation methods that can be used with regular expressions. The most common of these methods are test, match, and replace. The test method returns a Boolean value, either true or false. When some, or all of a string, is correctly matched with a regular expression, this method returns true. In contrast, the match method returns an array of all the matches in a string described by the regular expression. In our sample project, we're interested primarily in validating string inputs rather than determining the number of matches, so the test method is the most appropriate for our purposes. You can see how I've used this method in the validation function, here. In this code block, you can see how when this method returns true indicating a match, then we add a new valid class to that particular field. Conversely, if this method returns false or no match, then we attach an invalid class. These classes are CSS classes that we use to create the colorful borders around each field that you saw earlier. Let's dig into exactly what those classes are, how they work, and why we use them instead of regular hype styling. Our HTML text input fields require additional styling with CSS. Without it, these fields will simply adopt the default size and appearance of the browser where they are being rendered. This creates two potential problems. Firstly, the appearance can be somewhat different depending on what kind of browser is chosen. More importantly, the default appearance is ugly and needs to be improved. Additionally, without CSS, the accompanying hint text that we have incorporated to indicate whether an input is valid or not will be shown by default, which isn't what we want. You can see all these problems in this image where I have intentionally turned off the CSS styling. We could fix these issues by adding custom CSS code to each individual input field alongside the original HTML code. However, that would involve a lot of unnecessary work. Instead, it's more efficient to configure these styles as classes and combine them into a single file that's loaded at runtime. This has the added advantage of there being just a single location where these styles are configured, thus making updating them more straightforward. If you look at this CSS file, you'll see there are two types of rules being applied. Firstly, there are rules to override the default browser appearance for each text input. Then, there are a second set of rules that change the border color and hint text display depending on whether the input of the moment is valid. To load this external CSS file, you need to complete two steps. Firstly, load the file containing your CSS rules into the resource panel. I've called my file styles.css, and you can see it here. Then, you must ensure it's loaded at runtime. The easiest way to do that is to check the Include in Document Head option here. And that's it. We should now have a completed dialog with text inputs that are validated as the user enters them. Let's see it in action. So here is our final dialog running in a browser. This dialog loads with the placeholder text already showing. As soon as the user starts typing, the validation code kicks in, and continues to refresh with each new keystroke. Currently, the text entered into the password field is obscured for security reasons, but you could make that optional if you want. Our rules for the email address and phone number are also enforced as you type. Depending on your geographical location, you might want to include different rules for these fields or even some universal rules that account for all the possible areas where your application might be used. Of course, once this information is captured, you'll probably want to store it in a variable or transfer it to local storage, but how to do that is a topic for another video. Notice how we've captured and validated these inputs with a relatively small amount of JavaScript and a few CSS styles. From this starting point, it is possible for you to easily customize or extend this example for your own purposes. You can do this by simply replacing the existing string patterns with different regular expressions. Remember, there are already many of these available online. I've posted this example code to the Hype forum so that you can experiment or customize it in any way you choose. There is a link to that post in the description below. And that's it. I hope you enjoyed this brief introduction to capturing and validating text inputs in Hype. If you are interested to learn more about the neat things you can do with Hype, please check out my YouTube channel for other related videos. If you are interested to learn more about other things we are working on, please check out our website at alteredmindware.com or contact me directly at alteredmindware@gmail.com.